Welcome back to geometry class. Today we got a pretty important lesson on intersecting lines. We're going to combine intersecting lines with the concept of circles. Now where we're going to be looking at is, again, if you have intersecting lines, something like this, you got to keep your eye on that. That is the point of intersection. So that point of intersection in regards to a circle can happen three different ways. That point of intersection could happen inside the circle, which would look like this. It could also happen outside the circle, which would look like this. So this is outside. Or the last place it could happen is on the circle. That would look like this. So one of these we've already covered, and that's when that intersection is on the circle. So when the intersection's on the circle, it creates this inscribed angle, which, if you remember, is half of the arc it makes. So if that's a 60-degree arc, that would be a 30-degree angle. So we kind of covered that scenario where the intersection's on the circle. What we're going to focus on today is we're going to focus on when the intersection's on the inside and when the intersection's on the outside. So these are the notes that I gave you in your folder. They look like this. Objective for the day is to be able to find angle measurements of intersecting lines and circles. So first of all, like I said, we're going to look at the intersection here. There's a picture down here where it's on the inside. So the words here say the measure of an angle formed by two secants, which are basically these lines here, or they could be chords, which would just be the segment version of that. When they intersect in the interior of a circle, it's going to be half of the sum of the arcs that it makes. So if I focus in on this angle right here, this angle, what we're talking about, this angle actually makes two different arcs. The one arc that this angle makes is the forward direction this way. It's going to create this 100-degree arc. If you look at it backwards, it also creates this 40-degree arc. So what this theorem is saying is it's saying that angle measurement x is equal to half of the sum. So this is, you can see the calculation over here. Half of the sum of the two arcs, which are 140. It's 140 divided by 2 is 70. So that's a 70-degree angle. And so this vertical angle would also be 70 degrees. So that's what happens when the intersection's on the inside. Next, we're going to focus on when the intersection's on the outside. We kind of got carried on to the next page of your notes. It looks like this. So now, this is outside. So the measure of an angle formed in the exterior angle is still going to be half. But now it's going to be, instead of the half the sum, it's going to be half of the difference. So now again, here's the intersection on the outside of the circle. So now the angle we're kind of focusing on is this angle right in here, this little tiny angle where I placed a dot. So you'll notice that it also creates two arcs. Again, it creates this arc across the circle. I call that the big arc. And it also creates this little arc right here. So that angle, which I put the blue dot in, is going to equal 1/2 of the difference of the arcs. You always take the bigger arc first and subtract out the little arc, so you end up with positive numbers. So in this instance, it would be 110 minus 10 is 100 divided by 2 is 50 degrees. So that would be a 50-degree angle. So here's an illustration of what I've just talked about. Here they want me to figure out the measure of arc XY. Here I know the angle is 60 degrees. I got to figure out how big this arc is. Since the intersection's on the inside, remember that the angle, which I know is 60, is equal to half of the sum of the arcs. So I'm going to call this one X since I don't know what it is. So X plus the other arc, which is 20. So now I know what the angle is. I have a missing piece of the arc. So to solve this one, I probably multiply both sides by 2 to get rid of that half. So then I would have, what, 120 is equal to X plus 20. So subtract the 20, that means X is equal to 100 degrees. So this is a 100-degree arc. Then you could simply check, again, 100 plus 20 is 120. Half of that is 60, so it works out. So again, here's an illustration of the second one. So again, I have missing angle here that we want to figure out how big this angle is right there. Use a different color. So we're going to figure out how big that is. So that means x is equal to, now since the intersection's on the outside, it's half of the difference. So it would be x is equal to 1/2 of, the big arc now is 260 degrees. The small arc now is 100 degrees. So it's because the intersection's on the outside, I have to subtract instead of add. So then that's going to be 160 divided by 2 is 80 degrees. So this is an 80-degree angle. All right, so in here, kind of an illustration of everything I talked about. Here's the intersection on the circle. Again, the intersection's on the circle. The angle is going to be equal to half of the arc. So it's kind of hard to see here, but this is the angle they're talking about. It's going to be half of this arc right here, and that's this one. If you're looking at this angle over here, then you're going to take half of this arc. That's because the intersection's on the circle. Sometimes it'll be inside the circle. So then it'll be half of the sum of the arc. So again, this angle would equal 1/2 of this arc plus this arc. And then when the intersection's on the outside of the circle, then this angle would be half of the difference. So again, big arc minus the little arc divided by 2, which is what's illustrated right there. All right, so here are some example problems. So I'll get you started on a few of these. Let's see, number 1. I'm looking for the angle right there. The thing you want to notice is where that is. That's on the inside. So that means measure of angle 1 is going to equal half of the sum of the arcs, which I know are 40 and 52. So that's going to be what? 92. Half of 92 is going to equal 46. So that's a 46-degree angle. Over here, now I know what the angle is. It's 45 degrees. I'm missing that arc right there, but it's on the inside. So I'd say the angle, which is 45, is equal to half of the sum, which is x plus 28. Multiply by 2 to get rid of the half. X plus 28 would then equal 90. So then I'd subtract, and was that 62? So that means this missing arc would be 62 degrees. Here I noticed that the intersection's on the circle. Remember, when the intersection is on the circle, the angle that they're looking for would be half of the arc it makes. So the arc that's made by this angle is this big 120-degree arc. So the measure of angle 3 would be half of that, or 110. Down here, another example of where the intersection's on the circle. Intersections on the circle. They want to figure out how big the arc is. Well, since I know the angle measure, all I got to do is double it to find the arc. So I would do the measure of RT is 74 times 2, which is 148. So that arc would be a 148-degree arc. Now over here, again, I have these arc measures here and here, but when I calculate the angle, I got to remember that that's the angle I'll find. So I'm going to have to then do a linear pair. I'll do 180 minus that to get the angle that they want. So we'll call that angle X, and it's going to be half of 90 plus 130. So 90 plus 130 divided by 2 is 110. So X is 110, but I got to remember that's not the one they're looking for. They want the adjacent angle to that. So all I got to do is 180 minus 110, and that is 70 degrees. So the measure of angle 5 is equal to 70 degrees. So then on this one over here, and again, the intersection's on the circle. They want to find this angle, but they don't give me the arc. They give me the other side of the circle here at 160 degrees. So I'd have to do 360 minus the 160, which is what, 200? So the arc now is 200. The measure of angle 6 would have to be a half of that then, which is 100 degrees. Here again, where's the intersection? The intersection's on the outside. Since the intersection's on the outside, the measure of angle 1 is going to be half of the big arc, 80, minus the little arc, 40. So the measure of angle 1 would then equal, what is that, 40? Half of that is 20. Measure of angle 2, again the intersection's on the outside, so the measure of angle 2 is going to equal 1/2 of the big arc, 160, minus the little arc, which is 80. 160 minus 80 is 80, half of that is 40 degrees. So the measure of angle 2 is equal to 40 degrees. Over here, intersections on the outside again. Part of the circle is 220, that's this arc right here. I can get this remaining arc by doing 360 minus 220, so 360 minus 220. So that is what, 140? So this is a 140 degree arc right here. So now I'm trying to find the measure of angle 3. Measure of angle 3 would equal 1/2 of the big arc, 220, minus the little arc, 140. So 220 minus 140 is 80, divided by 2 would be 40. So this measure of angle 2 would be equal, or measure of angle 3 would equal to 40 degrees. Here, intersections on the outside, first thing I notice. Then the second thing is I know what the angle is, but I'm missing the arc. They want me to find this arc right here. So I know what the angle is. I know it's going to be half of the difference. The big arc is 70. Small arc is I don't know. Again, I get rid of the half probably. So then I'd have 20 is equal to, 40, because I multiplied by 2, is equal to 70 minus x. So then I'd probably add the x over and subtract 40 over at the same time. So that would be x is equal to 30. So that means the measure of arc JP is equal to 30 degrees. So then I have more examples here through 1 through 12 here. So I want you to try these. The answers are on the last page here. So again, the big takeaway here is, again, when the intersection's on the inside, it's half the sum. If it's on the outside, it's half the difference. If it's on the circle, it's half the arc. So again, inside looks like this, outside looks like this. On, typically you're going to see like a tangent and a chord. It'll look like that. So again, try those remaining problems. Also, I'll put a homework assignment up as well. Thank you for your attention. We'll see you soon.